Hi, welcome back to 345 Delta Foxtrot. I'm David Forgerson. It's been a while since my last video. I apologize for that. Had some other things that I had to do. I'll try and do better in the future. Today we're down in the shop and we're going to measure the strength of a couple of rivets. And this is just to show you how I do it. The apparatus is not particularly fancy or anything. Maybe you can find a better way to do it. My goal was to put together something that could measure the strength of rivets to an accuracy of, say, 10%. And I think this will do that. Undoubtedly, if you're willing to spend more money, there's ways to do things better. This is the apparatus right here. It's a scissor jack and a scale. The scissor jack I got from Harbor Freight. It's a Hallmaster 2.5 ton trailer RV scissor stabilizer, and the current regular price is $37.99. Not much else to say about that. Well, I guess there is one other thing to say, and that is I highly recommend that you secure it firmly to whatever it's sitting on, and in this case my workbench. We're talking about a few hundred pounds of force, and it's going to break suddenly, and you don't want anything to go flying around. The scale here is a crane scale. Got it off of Amazon. It's a 660-pound scale, or 300 kilograms. It was $27. The brand is Outmate, and the model is OCS-L. And I'll put a link to both of those in the description, so you can always get it there. The samples are fairly simple. For measuring shear, all you need is a couple of pieces of aluminum bar. I got this from Lowe's, and it is 6063-T5 aluminum alloy, and that's a magnesium alloy with some silicon. The magnesium content is between 0.45% and 0.9%, so call it 0.75% of magnesium. And the silicon content is between 0.2 and 0.6%, so call it 0.5% silicon. And it's 1/2 inch wide, a 1/16 of an inch thick. See if I can, you just take two pieces like this and rivet them together, like that. And here's one that's been riveted together. That's the factory head right there, and that's the shop head on that side. And then there's two holes for mounting it in the scale here. For measuring tension, I used C-channel aluminum. It's the same alloy. It's 3/4 inch on the inside width there, and that's what it looks like. Drilled two holes for mounting. You just take two of these and rivet them together, and here's an example. Here's the one we're going to measure. That's the that's the factory head, and I think you can see it pretty well in the camera there. That's the shop head. Let's see. So the rivets are 426 AD 3-4.5 rivets, and so the length is almost exactly optimum, almost exactly 1.5D. For the measuring the tensile strength, this sample here, on the shop head, the diameter was 140 thousandths, so that's almost exactly nominal. That's almost exactly 1.5D. And H, the height after it was squeezed, was 67 thousandths. And on the one for measuring the shear strength, the diameter of the shop head was 136 thousandths, so again it's right at nominal, and the height was 69 thousandths. So I already have a sample mounted up, so let me I'll give you maybe a little bit better view of the scale here. Okay, here's the crane scale. Turn it on. Has 3 different units. Right now it's set to pounds. Press that button. It measures in newtons. Press it again, it measures in kilograms, and you're back to pounds. And that's about all there is to know about it. You won't be able to see it but I will call out the readings as we go. All right, we're starting off, just a second here. Let me move some of this stuff, just in case things go flying. Okay, we're starting off at 0 pounds. We're expecting numbers, this is thick aluminum. Let me adjust the camera here, sorry. This is thick aluminum, so this is the optimum case. We'll do thin aluminum later. We won't actually film all subsequent measurements. This is just so you can see one time how I measure the strength of rivets. But since this is thick aluminum, the rivet is optimally riveted. The shop head is about as good as it can be. We're expecting strengths on the order of 200 pounds. So we'll start off, we'll go up to 100 pounds or so fairly quickly, and then we'll slow down. And ideally, you would have a motor drive this, and you would have a meter that measured kept track of the maximum weight or force recorded. This scale does not do that. You can buy ones that do. The trouble is the ones that are for reasonable price, they only go up to, I don't know, maybe 100 pounds or something like that. The ones that go higher get pretty expensive. So you're probably in the many hundreds of dollars range. So you just have to make do, just have to watch the scale as you go and keep track of the maximum reading. Like I said, if you motorized this and kept track of the maximum reading, that would be a major improvement to the apparatus. The other thing that you could do to improve the accuracy is to just measure each sample multiple times. And that gets a little tedious and time-consuming. But if we have trouble getting consistent results, then I'll try and do that. So let's get started. We're already at 19 pounds. Okay, we're up to just under 30 pounds. Okay, 35. Okay, we're at 43. We're right at 48. $57, 73, 90, 96, about 103, 111, 114, 118, 124, 130, 136, 141, 145 and a half, 152, 157, 164, 168, 176, 182, 186, 190, 191, 194, 198, 203, 208, 211, 215, 218, 220, 223, 225, 228, 229, no, 230, 231, 234, 237, 240, 41, 245, 248, 251. This is stronger than I was expecting. 252, 257, 263, 265, 271, 277, 280, 'Still about 280. It's peeling apart. It hasn't totally failed. You know, I just realized I should be wearing safety glasses. Well, let's call that 280 since it has peeled apart. I guess I can keep going. We'll go a little higher. We'll just keep in mind that the sample had started pulling apart at about 280. Oops, okay. Call that one 280. Let me write that down. Okay, I'm going to pause the video and take the sample out and remount the one for shear strength. And you don't need to watch that, it's pretty boring. Okay, yes, looks like we're recording again. Okay, I mounted up the other sample, and let's just get started here. Okay, that's about 7. That's about 33, 45, 74, 103, 119, 131, 141, 160, 178, excuse me a second here. It's a little cool out here. Okay, 197. 207. 214. 221. 227. 231. 235, 234, 237, 242, 247, 253, 259, 263, 270, 272, 278, 281, 289, 296, 302, 308, 309, 311 and a half, 314, 316, 318, 321, 326, 328, call it 328. Let me write that down. Okay. There's one other thing to do here. Let me take this out real quick. I'm going to need a screwdriver. Well, I'll pause this video for a second here. Okay, the last thing to do is to take a look at these samples and see how they failed. So this is the one where it was in shear, and this is the factory head right here, and it sheared off fairly cleanly on that side. I don't know exactly how well this is going to show up in the camera, but this is the other side, and there's just a hole where it used to be, and yeah, I don't think you're going to be able to see this, but this is the shop head of the rivet. I don't have to take a picture of that and blow it up or get a microscope or something, but it just sheared the rivet fairly cleanly in half. Now the other sample was measuring the tensile strength. What happened on it was the factory head, you know, it was countersunk, and the factory head just pulled through the countersunk hole, and that's the factory head. Again, I don't know exactly how well that's showing up. There's not too much to see. I think I described it fairly well. So we know that the strength for a flush head rivet, the strength of the factory head is about 280 pounds. And actually it was starting to pull apart earlier than that. I just wasn't watching it closely enough. you can see definitely how the sample got deformed, started bending, and like I said, we're looking at the optimum case here. This is pretty thick aluminum, way thicker than the thickness of the skins, for example. And when we start, measuring the strength of the rivets with the thin aluminum, I think we're going to get totally different answers. I've just done a couple of real quick experiments, and I think we're going to be getting numbers down in the 100-pound or less range. So anyway, that will be the topic for future videos. In this video, I just wanted to show you the apparatus and how I was measuring things. If you got any ideas on how to do things better, please leave a comment. But I think this is a reasonable way to get, like I said, numbers in the 10% ballpark range for the strength of rivets. And I'm surprised how strong these rivets were. Like I said, I did one or two samples with the thin aluminum, and you get totally different results. The next video will probably be different shop heads, squeezing them in different amounts. And I will not videotape all the measurements. I'll just give you present the results of how that came out. And then if I can find the time to make more videos, there's lots of other videos I'd like to make on the strength of rivets. I think that's it for this video. Thanks for watching. If you like these videos, please leave a comment or give it a thumbs up. That helps the YouTube algorithm spread the video to other people. I guess that's it. Thanks.